that's all we have prepared for today's talk. Thank you, and if there's any question.
Thank you very much. We actually have a couple of questions in the chat. Dusty B, you had the first question. You want to ask it yourself?
Yeah, so this question is for the first part, and then maybe I'll ask a question to Whitney also, which I've not posted. So for the first part, Ettore, I mean, you talked about L1, but I'm guessing that you would have modeled the other caches also like L2 and L3, and if so, is it true? And did you think of a TLB kind of situations? Because in the past, I have seen that there are sufficient amount of misses that come from TLB for this kind of loops. And I'm guessing this is looks like B waves to me, but I don't remember very well.
So yeah, so the answer is yes, you can have cache misses also in L2 and last level cache. The transformation here models L1, and you also some assumption that all the essentially it will get the cache line size from the I believe the TTI, the target transform information, and then it will compute the number of cache line, assuming infinite cache capacity, which is also not it's not true in any architecture. So it's an approximation of the loop caches, and doesn't really consider misses in L2 or higher type of caches.
Okay. And you talked about the Power 9 numbers. So anyone has done any study on the Xeon or AMD Zen servers?
No, for us, we have just done studies on Power, and actually on Power 9. That's and I would say future Power architecture as well. But no, I've not yet done any study on Intel or other type of architecture. Although I do expect that you'll get improvement across all this architecture, because I mean, if you get cache misses, then you're really not using the cache effectively, and so you should be getting improvement in most architectures.
Okay. One comment for Whitney, I think, regarding the placement. So we were also looking at some of this fusion pass part, and I think we need to put it at least after loop unroll. I mean, that's my opinion, because if you at least do an outer loop unroll, there may be kind of jamming situations that may arise with fusion. I mean, unless the unroll and jam is catching it. So that's a comment.
Yes, and in our experience with Excel, actually loop fusion is before unrolling. And if it's a good point that if we're doing outer loop unrolling, then maybe it's better to jam it afterward. But given that unroll and jam is happening in LLVM pipeline before unrolling, especially for this reason. So I think for those particular example, we're better off if we are directly trying to do it in unroll and jam.
Yeah, but the current unroll and jam is pretty restricted, so that's the
yes.
reason, yeah. Okay, thank you.
We have been also working on enhancing unroll and jam, and hopefully it will able to catch all those cases fairly soon. Yeah, thanks.
So, I mean, I'm going to add to what Whitney just said about loop fusion. Is a tricky situation, right? Because if so ideally, it depends from kind of your strategy. In the Excel compiler, we have this kind of strategy. We do fusion eagerly and very early before other loop transformation. And the idea, and without much analysis either, just fuse as much as you can. The idea is to make the context for other loop transformation larger, so that other loop transformation have more code to reason about in the same loop nest. But then we also have the ability to undo what fusion has done, because it may have broken vectorization and so on. So that's why we have a kind of like a loop distribution, loop fission paths that has advanced heuristics and take into consideration not just vectorization, but cache reuse and register pressure and so on. you could do it the other way. You could put the intelligence into fusion and even run these passes multiple times. So it's really, I don't think there is a definite answer where loop fusion should be done. It's always going to be a compromise.
Chuck, you want to ask a question yourself?
So can you just go to the fusion example? So I noticed that after the fusion, before the fusion, there's no dependency. After fusion, there is a dependency, yes, on V2. So, so how do you ensure the dependency won't actually cause correctness issues?
Question, safety analysis have to be done before fusion, or actually most of the transformation operate. So in loop fusion, we use different analysis to check for if it is safe to do before doing fusion. For example, alias analysis, dependence analysis, and SCAF. And one interesting observation we have is dependence analysis or SCAF can only, it works on what the current state of the code. So before loop fusion, the two instruction will be in two different loops, and there cannot be a single SCAF expression created for two instruction in two different loops. But we have in the fusion path that we do some with class that replace a SCAF expression of one based on one loop's induction variable and replace with this another loop. I think this work is actually done by Johannes.
Yeah. Well, to add to that, there is no loop. So yes, there is a dependency, but it's not, after fusion, it's not a loop carry dependencies, because the dependence distance between V2 is 0. Therefore, fusion is legal. Fusion is illegal when the dependence distance between vector becomes negative. So we need to check that, like Whitney said before, to prove legality. In this case, legality is being proven as fusion is legal.
Yeah, I agree. In this case, it's a true dependency with a distance of 0. So, I mean, yeah, so there is actually a legal test in place where to ensure this after fusion that you won't cause legality issues, right? Okay.
Safety check is already implemented.
All right.
For now, cost model is always saying it's profitable though. Yeah.
Okay, sounds good. Thank you.
Thanks.
Isan, you wanna ask a question?
Yes, my question was about Poly framework, because you have been spending time on developing this framework. I thought you may have also considered Poly, at least in the beginning, and so you may have some ideas about what are the shortcomings of the Poly framework.
We have not really considered the Poly framework because I mean, in past experiences, and that may not be true within Poly in LLVM, we found that it wasn't, there is some, like, it was just hard to understand and so on, and it had some compile time issue for us in the past. So we can focus on the existing framework within LLVM itself, although Poly may be it may work in some cases. We just kind of say, well, like, without being too ambitious, I guess, these are the type of transformation that are in LLVM, and we didn't think about let's reuse Poly completely, just add and try to enhance the existing infrastructure there.
Thank you.
Nick, you had a question.
Hi, this is Nick from Oregon. This is a very, very basic question. I thought the talk was very wonderful and informative. It looks like that's a very common loop that comes out in quantum chemistry. I'm assuming that loop probably came from one of the a DOE code. But my question is, I guess there's two parts. we write these loops in the code the same way we write them on a chalkboard or in a paper. And I guess my question is, I mean, I think the bottom line is LLVM, all these, it's a complex set of optimizations that have to be done to get the performance out. And at the end of the day, you still have to modify the code. Are there presently tools in an LLVM that will allow the average developer to do this analysis for themselves?
Okay, so see if I understand the question. The question is that I guess, in our own experience, we ran LLVM. It wasn't able immediately to do all this optimization for us, and so we had to do some work to improve the LLVM infrastructure to get to that point. And the question is there anything that a regular user could do to infer the type of transformation that are useful, that would be useful to do to the code? So
Correct.
my personal opinion here is that, so LLVM has this, people may have already discussed this yesterday, has a way to trace what each transformation is doing with the optimization report, which is essentially written for compiler developers. I think we have something in the appendix. So LLVM is going to tell you, oh, these loops have been fused or not fused because of certain reason. And whether this information is easily consumable by end user or not, my opinion is that this information is much more, is really written for developers, compiler developers. And it'll be a little bit hard for non-compiler developers to do anything, take any actionable, change their code to say, oh, yes, this is good. If I do this, then the problem is going to work very well. In some cases, it may be true. For example, I can think of one particular example, and this is more for C rather than Fortran. If your pointers, you pass to a routine, they are not restrict pointers, then a lot of loop transformation will be unable to analyze them, or they will have to version the loop to try to make some kind of, to prove that there is independence. What we have done is really use our own experience by looking at the code and say, this is what could be done to improve it, and that comes from a certain amount of experience in the field in looking at benchmark and try to analyze it. I am not aware, and perhaps somebody else in the audience, of particularly tools that are within in the LLVM infrastructure that's going to tell you, do this. This is like the stuff of the things that don't work. I know, for example, that there are tools like perf, like the performance analyzer on Linux, that's going to tell you how many cache misses are, what kind of event, and so on. Those are probably more meaningful to compiler developers or performance analysts. I don't know if that answers your question.
No, thank you. Yeah, no, it didn't. The slide that you're showing, I would say it's not consumable by the average developer to something that's actionable.
Yes, I think that the same question came in the panel yesterday. I think it's definitely an area where we could improve and either create a tool that can parse and consume some of this information, or just when you write some optimization reports, you need to think more about the user, right? Like, this is what the user would want to do.
Yeah. The step I usually take is run profiling to find the hottest part of the code, and then see, by looking at it, see if there's anything you think it should do, and look at the status in the compiler to see, is it done, and why is it not done? And there's 3 ways to look at what is done or not done in the compiler. One is the using stats. So for example, in k-means, it will tell you 3 of the loops are fused and how many loops is not, and what are the common reason. The remarks that are covered by other peoples can be easier to understand, although it's still not very easy to take action, but at least it tells you exactly where in the source code.
Oh, yeah,
And
you see, the
yeah.
treatments are not the same. There's something you can do.
Yes,
But,
and
yeah,
then finally, if you need to have more details, explanation of what is happening in the past, then we can use debug to see the traces of why the transformation is it doing what you expected.
Thank you. Thank you very much.